Okay, so this lesson is really just sort of a continuation of what we've already been doing, and we're using it to introduce what's known as bivariate data. Bivariate data, right here, simply means that you have two variables. You're comparing two variables. Examples might be miles per hour. Another common one, maybe inches of rain per hour, stuff like that. We've got two different variables. We've got miles and hours here and inches and hours here. We've really already been doing this. We've just been doing it within the context of linear relationships. So we're still going to be talking about linear relationships as an introduction to this notion of bivariate data. So if you'll look here at the examples, it's the same thing we've been doing. They're determining how much the y is changing over how much the x is changing. Remember, this is x and this is y. So it's still change in y over change in x. They did that right here. And they did 70 over 2 equals 35. Same thing over here. It's going up by 35s on this side, and over here it's going up by 1s. So 35 over 1 is 35. Okay? So they've given us, wait for that bell, some tables down here to finish. Okay, so let's look at what we've got going here. It says determine the amount of snow on the ground after 3 hours. So what I've got to do first is I've got to figure out how much this thing is changing. It says that it's linear, so that means that it is going to be a constant rate because they're already telling me it's linear. So I can assume that however much this one is changing is how much it's going to change all up and down the table. So we're going by 2's on this side and by 1's on this side. So this side is going to be going by 2's and this side is going to be going by 1. So this is a 2 and this is a 3. So I'm just going to go by 2's. Plus 2 is 7. Plus 2 is 9. Plus, oops, that should not say plus 2. Plus, can't find my whiteout. It should say plus 2. Plus 2. So it's going by 2's all the way down, and there's our table. So it's asking me for 3 hours. Determine the amount of snow. I'm going to have 9 inches of snow in 3 hours. All right. Number 2, determine the total cost of 6 prints of a digital photo. So again, I've got to determine a rate of change here. They didn't give me two that are right next to each other, but that's okay. I can still do it from here to here. And this is going up by 3. And this is going up by 2. So my rate of change is 3 over 2, which equals, now since we're talking about money, I know we always say, you know, leave your slope in fraction form, but since we're talking about money, I'm going to go ahead and change this to a decimal. 3 divided by 2, that's going to be $1.50. Alright, so this thing is going up by $1.50 every time. So in between 2 and 4 would be 3, 4, 5, 6, and 7. My rate of change is $1.50. So from here to here, let me do it inside here. This will be plus $1.50. It's going to be $4.50 plus $1.50 is 6 plus 150 is 750 plus 150 is 9. And then 9 plus $1.50 is $10.50. Okay? So it says determine the total cost of 6 prints. So it would be $9 for 6 prints. Not a lot different from what we've already been doing. Okay, on the next page it says, does each graph represent a linear relationship? Remember, linear has the word line in it. So if I were to connect these points, would it make a straight line? I'm going to get a straight edge and see if I can connect these points, and lo and behold, yes, it makes a straight line. So my answer to number 3 is yes, it's linear, because the points form a line when connected. Okay, this one, if I connect the points, that is not a straight line. I cannot pass a straight edge through those points. So no, it's not linear, because it doesn't form a straight line. When connected. Again, the word linear has the word line in it. Okay? Alright. Numbers 5 through 8 have to do with this graph here. It says the graph shows a linear relationship. They are forming a straight line. That means it's going to have a constant rate of change. Between the number of days is my x, and the total cost, this is my y, including the initial fees. The initial fees is going to be your y-intercept. Okay, so choose the correct answer. Number 5 says the slope of the line is. Remember, you've got to go from point to point. So, looks like it's starting here. And remember these stair steps from last unit? Okay. Looks like we are going, let's see, up by 30s. Is that right? Yes. 30, 60, 90, 120, 150. So it looks like we're going from point to point. We're going up 30 units and over 1. Up 30 and over 1, because see, 2 units is equal to 1. So 30 over 1. So that means that that is the slope, which equals 30. So my answer is A. We're going up 30 units and over 1. See, every 2 marks is 1 unit along the bottom. So up 30 over 1, up 30 over 1, up 30 over 1. The y-intercept, remember, is the point where it crosses the y-axis. Where does this thing start? Where does it begin? This thing starts right there at the 60. So B. Okay? Y-intercept is 60 because it starts right here. By the way, that makes this relationship non-proportional, right? Because it started at the 60. Okay. It says an equation for the line is, remember, your equation has to follow this format, y equals mx plus b. So you put your slope where the m is, so that's 30x, and my y-intercept is 60 plus 60. So that would be answer choice C. Alright, and the cost for renting a car for 3 days is, you can do this a couple of different ways. I could go up, I could go to 3 days and go up to the line, and that is going to cost me, that's a 150 right there, $150. Or you could fill in your equation, and you could say the cost is going to equal 30 times 3 plus my starting point of 60. 30 times 3 is 90, and 90 plus 60 is 150. Either way. Alright, 9 and 10 says, explain whether or not you think each relationship is linear. In other words, does it have a constant rate of change? Alright, so let's see. The total pay and hours worked for a babysitter who gets paid per hour. So if they get paid per hour, then yes, this would be linear. Because the constant rate of change is $8, right? It's constantly changing by $8, and that doesn't change. If she works 1 hour, she makes, let's make a little table. If she works 1 hour, or he, she makes $8. 2 hours, $16, right? 3 hours, $24. This thing is always changing by $8. It's got a constant rate of change. Alright? This one's not quite as obvious. The perimeter of a square and its side length. So here's what I'm going to do. I'm going to create a table. Right? And this is going to be the side length. And this is going to be the perimeter. So let's just say the side length of the square is 1. The perimeter would be 4, right? Because the perimeter is the distance around. Remember, perimeter would be 1 plus 1 plus 1 plus 1. Right? You're just adding them all together. So if my side length of my square was 2, that would be 2 plus 2 plus 2 plus 2, or 2 times 4, which is 8. If my side length were 3, that would be 3 plus 3 plus 3 plus 3, or 3 times 4, which is 12. And I could keep going. 4 would be 4 plus 4 plus 4 plus 4, that's 16. Okay? Is this a constant rate of change? These are always going up by 4s. So yes, it's linear. Because the constant rate of change is 4. Okay? And that's it for this lesson. Not a lot of new stuff today. We're just kind of easing you into bivariate data and scatter plots. So very soon you'll see how this is tied into our next unit over data and statistics. And that's it for today.